Today I'm going to explain how to connect the AND gate, the XOR gate, and also a triple input AND gate. I'm going to explain 3 gates, and if you know them, then you will be able to connect and test any other logic gate. Okay, let's start with the AND gate. First of all, let me remove the power supply. This gate has a number of 74LS08 and it is called quad 2 input AND gates. Quad means 4. 2 input AND gates means we have 4 AND gates, each with 2 inputs, and we can see this from the IC itself. We have 4 AND gates and each one has 2 inputs. And this is our truth table. As you see, it will be high only if the input A and B are high. Otherwise, it will provide low or 0 volt. So let's start by connecting this gate. It is 0, not this one. Yeah, it is this one. You can see the IC number. It is called 08. Okay. So I'm going to connect this gate again as we did in the previous video. I'm going to connect this gate here. In the previous video, I already explained how to connect the VCC and the ground on the NOT gate. They are exactly the same. So we have here the VCC on pin number 14, the VCC, and the ground is on pin number 7. This is our first pin, and we know that from this notch here or the hole here. So this is our first pin. This is number 7, number 8, and number 14. Let me focus a little bit. Okay, so this is our pin number 7 to the ground and pin number 14 to the VCC. We have 2 inputs, so we have to connect 2 switches to these 2 inputs and an LED to this output. I'm going to draw the two switches. So this is the first switch circuit to the ground, and the second switch circuit, a resistor to the ground. And then we connect these 2 circuits to these 2 inputs, and the output from this circuit is a resistor with an LED or LED. That is what we need to do. So let's start with the switches. We already have one from the previous video, so I'm going just to revise the connections. We have resistor to the ground. This is our resistor to the ground. Okay, and the blue line is the ground, and we have the second pin of the switch to the VCC, the second pin of the switch here to the VCC. So this is our first switch. Let's now connect the second one. So I'm going to connect also here a resistor to the ground, and then a VCC connection to the other side. Okay, we finished already this one. So I'm going to connect the first pin to the first pin here, because we need to connect the first switch to pin number 1 and the second switch to pin number 2. So I finished this one. I'm going to connect this one from switch number 2 to pin number 2. So we need this line here. So from this point, it is a little short anyway. We can make 2 connections. So from the second pin here to this point, and from this point to the second pin. Let me bring something short. So from here to the second pin. The next is to connect pin number 3 to the LED. So this is our resistor that we should use with the LED. So I am going to connect this here, pin number 3, to this pin. And let's take another resistor here. You might ask why I didn't just connect the new resistor here, because I think this one is 1 kilo ohm and this one is 330, and we need a 330 to the LED. I don't remember the values, but I'm just explaining this one. It is good to have a 1 kilo ohm, and this one it is good to have 330. Now let's connect the LED, and as we explained the previous, the large part is the negative and the small part is the positive. So I'm going to connect this to the resistor and this to the ground. So this to the resistor here, and the second pin to the ground. Okay, so it is not working. Does this mean that we have a problem in the circuit? The answer is no. Okay, I don't know if we saw the power supply. We have the power supply 5 volts as usual. And now what we need to do is to try this 0 0. Let's start with 1 0. It is not working. So let's try 0 1. It is not working. Let's try 1 and 1, and it is not working. Okay. The reason for that is I forget to connect the power supply. So I'm going to connect the green one to the red one here, the VCC, and this is to the ground. And as you see, it is working. Let's try 1 0 or 0 1. It is not working, but 1 and 1 is providing high here or 1 here. Okay, so now we tested the AND gate. Let's test the XOR gate. So I'm going to remove the power supply, and I'm going to remove this IC. We can make another connection here, but I am just doing this because we need exactly the same circuit to the XOR. So this is our circuit to the AND gate. Pin 1 and 2 are inputs. Pin 3 is the output. If you look at the XOR gate, it is exactly the same. Pin number 1 and 2 are inputs, and pin number 3 is the output. So that's what we need. And by the way, low and low provides low, high and high provides low. If they are not the same, then we get high. So let's get this IC. This IC is, let me show you the number, 47LS86, and you can see the IC number here. So this is pin number 1, this one. So I'm going to connect this one to the left side. So let's connect it here. Do we need to do anything else? The answer is no, right? So what we need only to do is to connect the power supply. Okay. Now it is off because we have 1 and 1. Do you see the switch? Yeah, I think you can see it. So let's make 1 and 0, 0 and 0, and then 0 and 1. Again, 1 and 1, 0. 1 and 0, 1. 0 here and 1 here, or you can start from right to left. Anyway, 0 and 1 provides 1, 0 and 0 provides 0. That is how to connect a 2-input gate. 2 inputs gate. Now let's do something else. Let's have this IC here with this number, 74LS11, 74LS11. This is called triple 3-input AND gate. So the AND gate has 3 input, and the triple here means we have 3 AND gates. So we have 1, 2, 3. So the IC number is, as I said, 74LS11. Let me bring this IC. You can see the number here. Let me show you. Okay. So what I'm going to do is, we have pin 1 and 2 as inputs. That is correct. Our connection is similar to this. We have 2 switches are connected to pin 1 and pin 2. But the problem here is pin number 3 is not the output for this one. So we need the output on pin number 12. So I'm going to connect the LED on pin number 12. So let's remove the LED. By the way, we need to replace this IC with our triple 3 input gate. Okay. So this is the hole here, and this should be on the left side. Let's remove the power supply and then connect this pin here. Let's remove this resistor because this is for the output. This resistor should be on pin number 12. So this is 14, 13, and 12. And then let's connect the LED. We know already the positive and negative. I'm not going to repeat everything many times. So now we finished the output on pin number 12. So we also connected these two inputs. We need another input, and the third input comes from pin number 13. Okay, so I'm going to connect another input. So we need this switch, the third switch here. So I'm going to connect the resistor to the ground, the other side to the VCC. I hope that we get a problem, and I hope that I see it is not working. That is good because I need to teach you how to diagnose the circuit. But anyway, everything is working fine until now. So we connected the third switch, and now we can test our circuit. Let's connect this and this. Let's just test the table. It is gonna be high only if the A, B, C are high. Otherwise, it will be low. Okay. So let's start by 0 and 0 and 0. As you see, 0, 0, 0 provides 0. 1, 0, 0 provides 0. 1, 1, 0 provides high, provides 1. That means we have a problem, right? Because we should only get high here if these three are high. But now we have high, high, low. So we have a problem. Let's measure the voltages to see what is our problem. This is our voltmeter, and this is our ground, and this is our VCC. I'm going to connect this one to the ground and this one to the VCC. By the way, this is high. What does this mean? It means that we have 3 inputs high. That is the only option to get a high value on the output. So I'm going to measure the first input. It is high. The second input is high. This is the third input? No, it is not. The third input is on pin number 12. So I'm going to measure this. Oh, sorry, this is not the third input. The third input is on, let's revise this. It is on pin number 13. So again, this is to the ground, and pin number 13 is here, right? So I forget to connect a wire from here to pin number 13. I hope that you already catch this before I found it. So from here to here. I think now you can see that this is 0 now. So let's connect this a little. Okay, so we have 1, 1, 0. Let's test 0, 1, 0. Let's test 0, 1, 1. And let's finally test 1, 1, and 1. Now, I explained to you how to measure a 2-input logic gate, a 3-input logic gate, and 1-input logic gate in the previous video. I think, in my opinion, that you are able now to test any logic gate. In the next videos, I'm going to make it a little complex. So that's all for today, and see you in the next video.